I'm the professor, and today we'll be discussing the divisibility rule of 5 to the power n. So it's similar to the one that we discussed for 2 to the power n. The only difference is that earlier we used to check for even numbers. This time we'd be checking for 5 and zeros and other things that are related to 5 to the power n. So for divisibility rule of 5, we just check the last digit or the units digit. If that is divisible by 5, we say that the number is divisible by 5. For 25, we need to check the last two digits because it's the second power of 5. 5 to the power 2 is 25. So we check the last two digits, that are the tens and units digit. So we check it side by side, the number, the tens and units digit placed side by side, the two digit number that we get. If it is divisible by 25, we say that the whole number is divisible by 25. For 125, we check the last three digits, or I can say the hundreds, tens and units digit. If these three number formed by these three digits is divisible by 125, we say that the whole number is divisible by 125. So it's very much similar to what we discussed for 2. For 2 we had to check the last digit for divisible by 2. For 4 we had to check the last two digits divisible by 4. For 8 we needed to check the last three digits divisible by 8. Similarly for 5 we check the last digit, the last two digits or last three digit. For 5, 25, 125. So you may be required to go till 625, but hardly ever you'll come across beyond that. Similarly for 2 also, maybe till 16, but not beyond that. Even 16 is very rare. 8 is very much available, but going beyond 8 is very rare. So we have some examples in the similar format. For divisibility rule by 5, we'll check whether these two numbers are divisible by 5 or not. So for this number, and again the same rule applies here also. We can also consider as the remainder of the number when divided by 5 to the power n. So we can also consider as the remainder, the leftover that we get when we divide it by 5 to the power n, maybe 5, 25, 125, 625 and so on. So for this one, if we check for divisible, whether it is divisible by 5 or not, we take the last digit, the units digit, and check whether it is divisible by 5 or not. For 5, it's very simple. We have to have 5 or 0. It's neither, so it is not divisible. The remainder in this case is 3, because 3 when divided by 5 will leave a remainder of 3. In this case, since it is a 5, it is definitely divisible. And the remainder, since it is divisible, the remainder is 0, or you can say the remainder is 0, so it is divisible. Now for 25, we need to check the last two digits. Since it's a 0 and 0, 0, 0 is definitely divisible by 25 because it will leave a remainder of 0 as well. So it is divisible. Here we have 45. The last two digits, if we pick up, it is 45. So 45 when divided by 25 will leave a remainder of 20. A remainder of 20 means it is not divisible because 20 is not equal to 0. We have to have a remainder of 0 for the number to be divisible. Here we have a remainder of 20, so it is not divisible. Now we come to this part. So we have a 725 and we need to check whether it is divisible by 125 or not. 125 4s is 500, 125 5s is 625, so it's 100 more than 625, so the remainder is 100, so it is not divisible because we have to have a remainder of 0 for the number to be divisible. We don't want to bother ourselves with what is in front. We just need to consider at the last 3, 2 or 1 digit for 5 to the power n. Similarly in this example, 125 2s is 250, the remainder would come out to be 0. So it is divisible. So that's about the divisibility rule of 5. In the coming videos sections, we will discuss the divisibility rule of 3, 9, then we will go on to 11 also, and some of miscellaneous divisibility rules like of 6 and 12, etc. So stay tuned, keep studying, stay safe, and the professor. Bye bye.